My name is Cody Cole. I'm a teacher at East Beauregard High School in DeRidder, Louisiana. As a teacher, I'm passionate about students seeing the utility of their education and the need for rigorous instruction. It's so important that students connect with what they're learning and understand how it fits into a bigger picture. When we learn things in isolation, we miss out on a huge opportunity to apply value to the content at hand. It's crucial that students see this connection, especially with concepts that often appear abstract. In the sciences, we're able to discuss these concepts and perform demonstrative experiments that prove the reality of the content. This has been a tenet of science instruction for decades, and in more recent years, though, there have been a movement to have students use this knowledge to develop and carry out their own inquiries, where they're able to develop their own questions and pursue autonomous ideas that has the potential to lead almost anywhere. Most of the major goals of my instruction are to teach students how to ask questions and then use those questions to drive instruction. This may be as simple as a Google search or as complex as a months-long experiment. But in doing so, I try to instill in them a critical eye, validating sources and analyzing data. This video highlights a 2 to 3 day lesson that introduces our unit on mixtures. We do not have a standard curriculum and are allowed to meet the Louisiana State standards for science using teacher-selected or generated materials. So I developed this lesson to meet the high school physical science standard 2.6, whose performance expectation says the learner will plan and conduct an investigation to gather evidence to compare the structures of substances at the macro scale to infer the strength of electrical forces between particles. This group is a mixture of juniors and sophomores in a general education classroom. Some students have IEPs and 504 plans. They come from a variety of economic backgrounds, half of which qualify for free or reduced lunches. Additionally, many are raised by extended family members or in the foster system. Prior to this lesson, students have completed units covering subatomic particles as well as ionic and covalent compounds. This unit began 2 days before the lesson that you will see today with an introduction of inter- and intramolecular forces. Students were challenged to hypothesize why compounds or elements react with others, but some don't. This led to a discussion in a small project on mixtures of matter. On the second day of the unit, we discussed how mixtures are able to be separated using physical properties of those substances. This included a review of polar and nonpolar molecules as well as ionic compounds and pure elemental substances. We concluded the lesson with a review about how to determine the validity of a data source and a sneak peek of the lesson that you will see in this video. Students were provided with a spreadsheet to begin collecting information about various techniques to separate mixtures. This lesson is naturally differentiated for every learner as it's directed and driven specifically by the students. However, I've provided a list of possible sources for students needing additional accommodations. The students here are completing their initial independent research. They were told to find various techniques to separate mixtures from valid internet sources. While they researched, I questioned and roamed around the classroom asking students how they would determine the validity of their sources. We also discussed that some techniques will not be applicable for the upcoming scenario. However, they were encouraged to consider any method that they came across.
Click off of whatever cell you're on, and it'll make sure that you save whatever's on there. But it'll still open right back up whenever you open it back up. It'll be all right. The Chromebooks are pretty good about saving your information. Except when they're not, and then, oh well, you get to redo it all. It's my favorite. So there's been a disaster here in Dry Creek.
When?
Outside of the school, there was a 18-wheeler that overturned carrying hazardous materials. Now, we have been commissioned to determine how to clean up our hazardous materials outside of the school. And I have taken upon myself to enlist the help of Mr. Cole's helpful hazmat handling agency. That's you guys. My nice little chemical engineers, to help me clean up this chemical spill. Now we have a spill, so what's probably the first thing that we need to do in order to determine how to properly clean up this chemical spill?
Identify it.
We got to identify it, right? We got to know what we are. In order to identify it, we've got to get pure samples of stuff. And so here's the information that we do know about our chemical spill. That the tanker was transporting a mixture of compounds. So not just individual substances, there was a mixture of things. But the number of substances is unknown. Preliminary investigations showed that between 4 to 7 substances were being contained, along with those substances that may have been contaminated by the road whenever all that mess fell out on the highway, right? So you guys are going to be charged with identifying individual isolates. You're going to be given 35 milliliter samples in these nice little conical tubes. And each of you are going to have specific roles to play. The leader's going to make sure everything's good and rolling the way it should go. Your materials coordinator is going to be the one that's going to collect your materials that you'll need and put everything back and know where everything goes and where everything is. Your safety officer is going to make sure that you identify any kind of unsafe situations and that you deal with them appropriately. And your quality control manager is going to make sure that you're doing things the way that I want you guys to do now. I'm going to divide you into your groups here in just a second, and I'm going to give you this plan of action. Pull it up here, show it to you. There you go. So you're going to tell me who's going to play what role in your group. Now, whenever I give you your sample, you're going to start thinking about what your separation techniques are and what methods you want to follow first. What's the first thing that you're going to do? And you're going to list that method. Please bring your Chromebooks with you and go to your appropriate lab table, with the exception of my orange people. And I'll space you guys out here in just a minute.
I frequently change up grouping in my classroom. My desks are numbered with various colored labels. This allows me to change my groups based on numbers, colors, rows, and columns. This keeps students on their toes in their collaborations. Additionally, I have my seating arranged in a way that allows me to choose grouping arrangements that cater to ability groups as well as random dispersions.
You can invert it. Make sure it's closed real tight. All right, so I got you. Okay, yeah, you can
Oh wait, there's a liquid.
I think it's like
What is it?
Is
that tinfoil?
Yeah.
I'll have a filter paper, which will essentially do what you need to do. As far as separating the solids from other solids, you're going to have to come up with a better way than to, unless you have you want to bring a strainer or something like that. You know what, you might do it through, that might be big enough. Yeah, that would be big enough for it. Okay. All right, so once you've identified your roles, now you can compare your separation methods and look at your sample and try to identify how you're going to start. Now the paper that you write, that plan of action paper, you want to list them in the order that you think that you're going to do them. So you need to consider, looking at your sample, how you're going to start. Every method you use, you have to have a validated...
Using strainer, we have to use the strainer to take out the bigger pieces in there, so we're not...
Oh, I got some.
Right? Keep them all in line for real.
Okay.
Alright. So materials needed, let's see. Let me see.
Oh, you need the filter paper.
Filter paper, what else?
You're gonna have, so there's at least 4 things, right? So it means you have to have at least 3 separations.
And next we're gonna probably
Filtration. Like filtration, distillation,
Now
and...
there may be more than 3 things. 4 things.
I don't think you have to
have a thing?
I wouldn't do...
Do I know?
Do you have a thing for coffee?
Yeah.
I wouldn't do I would actually do...
Not for everything, but
What about nuclear decomposition?
so I don't.
Hey,
And like fractional distillation, we don't have cooling towers.
Where's the hydrogen collider?
Yeah.
I wouldn't actually do
The tinfoil is stuck to the side, but this one's just floating.
How about that?
Wait, so are you going to say that the green liquid is pure already? We just have to leave it out?
You have to make that decision. We don't know, right? We just got the sample. We have to identify if it is a liquid without getting the top liquid.
I'm pretty sure evaporation will...
Yeah, you take out the top liquid.
Okay, but that's separating 2 things, right? So you need a mechanism, or
like we think it is. It should evaporate faster than the bottom.
okay. So I see what
We'll
you're
go through
saying.
the tube and turn back to pure water. It will also leave along, if it's salt water, it would also leave salt in solution, which evaporation will take care of.
So if we do one more, it would give us potential.
But if it's not, and you evaporate all that out,
Magnetism is the last thing we could do, and we could use what we filtered out.
I'm trying to tell you something without telling you something.
He's trying to tell us our method isn't going to work
That's
without
not
telling
water.
us our method.
That's not water. That's not water.
It's not water.
Is it alcohol?
And I won't let you distill it.
It is alcohol.
It's alcohol.
No, it's not alcohol.
Oh, then
Well, then why
Is it
can't we
flammable?
distill it?
is it flammable?
That top solution is a pure solution.
Okay.
So is it
But-
contact solution?
Distilling is still a good idea, but not for the top liquid. So you got to separate the top liquid from the bottom liquid. Add that one in there.
We use a drop.
These funnels are useful in separating non-mixing liquids.
This is scary.
That's scary.
Yes,
That's
it
gonna hurt
is.
you now. So when you're filtering something, what's gonna happen whenever you pour something on top of that?
It's gonna fall.
It is.
Do you have a rubber band?
I don't.
All right.
But you do have a funnel.
Yeah, maybe. Okay.
It's coming out.
Is it going through the thing?
I've seen a couple of milliliters for a couple of.
Yeah, I told you to do that.
Yeah.
I knew it was magnetic.
We're doing it science.
You should be doing something a little bit.
I'm scared it's gonna
You're
fall
doing
off.
great. You're doing great.
Okay, well
It's
look.
gonna fall off. That's the point, right?
Okay, yeah.
Because then you'll just collect it from what's sitting there. There you go.
Okay, that right there. What are you doing?
We're using a dropper pipette to remove the top liquid from the bottom. It's not working as good as we thought it would. It's not working very efficiently, so we may have to change our method.
How's it coming?
It's not
What's our problem?
it's not extracting as good as we thought it would.
Okay.
So I mean the only thing I can think of is maybe putting it back in the original container and
What are you trying to collect?
the top
The
liquid.
top liquid? Okay.
So but maybe we should try to collect the bottom liquid? Or would that
Did
be-
you look at decanting maybe?
We could do that.
Yeah.
So could we put our new method down there and scratch it out and then get you to sign it again?
You can, absolutely. Yeah, but you're right, you could put it back in there. Yeah, and that would make it all tighter together. Or you could put it, you got another cylinder somewhere, you can put it in.
That's what those holes are for.
That's not what those holes are for, but isn't that fantastic? Yeah. Don't trust it.
Distillation.
Getting hot. This is cooling it.
Oh, is this
Cooling the
directly
smoke. It's dripping.
The next thing that you gotta figure out, you can't get that out of there. It's just not gonna happen.
So it's like
So,
cooling it?
but there was stuff there, right? So what does that mean that you need to do? How can you collect that stuff now?
Evaporation.
Once students collected their isolates, they were asked to classify their isolates based on a set of commonalities that they observed. Most students recognized that substances were dissolved in the bottom liquid and rightfully concluded that it was water. Because of its polarity, other substances were easily dissolved into it. The next day, students will be asked to create data tables to show these connections. As an extension, they'll be challenged to determine another real-world application that uses techniques used in this activity. In previous years, some suggestions include other chemical spills, analyzing samples from extraplanetary sources, and identifying some material in a student's shower. Finally, students were given an opportunity to pose their own questions to pursue additional inquiries. I do believe this is a very effective lesson. The students were continually engaged and worked diligently with their groups to meet the objectives. Their comments, discussions, and procedures were well informed and showed deep understanding of the content presented. Upon the development of the rubric for this activity, the students worked together to determine precise criteria for their evaluation. Thinking about this lesson in the future, I'm considering rearranging my curriculum to complete this activity after we've learned how to quantify solutions. The blue liquid may show up again later in the year whenever we get to that point and we can finalize this investigation. This is my favorite type of learning. When students are involved in the development of their instruction, it becomes something that they're proud of. They talk about it in the hallways and with their parents. The content comes alive, and they learn that they have the capacity to pursue knowledge independently. They understand that what they are learning has context that is applicable to them, and they see that this daunting challenge is something that can be managed methodically and with good planning. I tell my students all the time, you can't learn it all at once, just like you can't change it all at once. How do you eat an elephant? One bite at a time.
What do you mean? I wrote his name.